Hi, everybody. Hi, my name is Itai, and I have the pleasure today to talk about a very, very interesting, one of the most, I think, interesting attacks, cyber attacks that were ever conducted. And this was the case of CCleaner hack. So CCleaner was like a supply chain attack that we're going to explain exactly what happened there. I'm sure that a lot of you are already familiar with it, but I'm also going to present our own research about this attack and also about the malware that was involved in this threat. So just a few words about myself before talking about the interesting stuff. My name is Itai. I'm the CEO and co-founder of a company called Intezer, which is actually focused on malware analysis and threat detection. And before founding this company about 2 years ago, I was leading the incident response team, the CERT, of the Israeli military. So really most of my daily job was to deal with nation-sponsored threats. And actually, I'm really glad to speak about this attack, the CCleaner hack, because I've seen many attacks from very sophisticated threat actors, but this is hands down one of the most compelling stories I have seen. So this is me, and what I'm going to talk about, well, my talk is going to be divided into 3 parts today. First, I'm going to speak about what is a supply chain attack to begin with, just to make sure that we are all on the same page. Secondly, I'm going to dive into the specific case of CCleaner that was back in September last year. And lastly, I'm going to present our own company's research about very interesting code connections or links between the CCleaner hack and APT17. So, first of all, really what is a supply chain attack, right? So instead of the traditional way of attacking an enterprise, which is directly infecting a company through phishing emails, open ports, you name it, in a supply chain attack, you use a third-party supplier and infect this supplier like a software vendor or other, a company that the target company is working with. You infect this supplier, so in the end, the target company is also infected as well. Now, I'm sure a lot of you know about that, but I think there are 2 interesting points about supply chain attacks in general. So one is that they are extremely hard to detect, right? Because you have already this open processes and a trust relationship between the supplier and the target company, so that, most companies, and I'm saying it very in the nice way, most companies don't really check the stuff that is going through their suppliers, right? So tearing down even the most sophisticated defenses can be quite easily conducted utilizing supply chain attacks. And the second point that is very interesting about a supply chain attack is that the potential damage of a supply chain attack is actually exponential, because for one supplier, you have many companies that are working with them, right? There are suppliers with hundreds, thousands, or even millions of customers. So if you infect the supplier, you basically can infect all of its thousands or millions of customers. And I personally believe that the combination of these 2 points, that it's very hard to detect, and also the potential damage is huge, that what makes supply chain attacks a really big threat to us in the information security community, right? And I'm sure that everything that I just said is not news for you, but I think that we always should remember this is a threat that was not, let's say, does not have yet solutions that solve the whole problem, and we should work on it, right? Now, one thing I want to mention is that, it's not easy to conduct these sort of attacks. But if you have the resources to do it, you get much more for your money as an attacker. Anyway, let's dive into our specific case, which is the CCleaner hack, right? So what is CCleaner to begin with? CCleaner is a very well-known software, a free software that many of us use in our computers to, let's say, clean up the junk, right? Like adware, unused registry keys, and so on. And because it's so effective, there are millions of users of CCleaner worldwide. And actually, this software was developed by a company called Piriform that was acquired by the security vendor Avast. So they have developed this software. And back in September last year, there was a very exciting news, I think, that two different companies, both Cisco and also Mofisec, have discovered that the latest update of this legitimate software was actually patched and backdoored with malicious code. So just to, say it again to be clear, we're talking about a legitimate software that was published in legitimate places like their official website and so on, that was patched with malicious code. So everyone who installed this completely legit software was infected by this backdoor or by this malicious code. So the effect is that indeed everyone who downloaded this update was infected, but this malicious code that was initially implanted in the legitimate software was actually containing only a small part of logic, only like a small part of a code. In this code, what did it do? So this code was actually only reading several pieces of information from the target's computer, such as the host name, the domain name, and that's it, right? Just getting the most clear indication about what is the victim that I'm currently installed in. And then this malicious code has basically sent the information, this basic information, to the command and control server for further steps. And this is where the interesting part comes along. And this really, one of the reasons that this attack is so interesting. The attacker was apparently very, very picky. He was very picky in his targets. So although millions of users, because we're talking about a software with millions of users worldwide, were infected, actually the targets were very, very narrow. So after receiving the information about who are the victims, then the attacker had decided who to deliver the second stage payload, right? So not all the millions of customers have received this very special second stage payload, but only just a few. So we're talking about 40 organizations, commercial companies, very big commercial companies, who were the actual targets of this attack. And by the way, they include Microsoft, VMware, Cisco, and some more. Now, the very, very gifted and talented Cisco Talos team have received an image of the CNC server. And they have, they could actually query the database of the attacker. So we actually learned a lot about this threat in the eyes of the attacker by using the image from the CNC server. So see how many infected computers there are, see how many government and banks were infected, really a very big potential damage. But in the right-hand side, you can see the actual companies who were the real targets of this attack. So really only a few, right? So all of this description about the attack itself is really a publicly known information, right? And although I think that is extremely fascinating, as I mentioned before, I think that even more fascinating is what we discovered when we actually took a look into the malware and the malicious code that was injected into CCleaner. So just a quick background. My company, Integer, is focused on analyzing code and actually understanding code similarities and code reuse connections to other known malware or software. And this research was not different. We spent time focusing on researching on this specific aspect of this attack. We took the CCleaner and all of its modules, all of the code that we can put our hands on, and we tried to figure out with our technology the connections between the CCleaner attack and other well-known software or malware we have seen before. And really just a background about how we do this, because this is B-Sides, and I want to share also the technical aspects as well. So what we created is a very cool database that contains billions of tiny pieces of binary code, right? So we took a lot of software and a lot of malware, dissected it into many, many small pieces of binary code, and then we fed our huge database that we like to call the code genome database. So you have, for each and every piece of code in that database, you can know exactly which software it came from, how many times we have seen it before. So a very rich information about tiny, tiny fragments of code. Now, I'm not talking about like a whitelist or blacklist database that you have information about file hashes, right? I'm sure you know what's that. But I'm talking about a reputation database or an intelligence database about tiny pieces of software, tiny pieces of binary code. And when we have an unknown file that is given to us for analysis, we are essentially able to dissect it also to these pieces of code and comparing them into our big database of code. So in the end, what we can do, and this is what we've done also with CCleaner, we can identify the origins of every piece of code in that file or in any given file. Now, a lot of people ask me, in many cases, okay, code reuse is, a very big phenomenon. It's obvious that people do not love to rewrite their whole code from scratch, right? I'm sure you know what I'm talking about. But code reuse, in a lot of cases, is consisting of, using libraries, stuff that the compiler adds, and a lot of stuff that are, mostly common. So if we find code reuse between a certain, malware to another threat actor, doesn't it mean that maybe they just used the same library? So this is where the method of how you should, detect code similarities comes in place. Because think about it. If you have a database and you have this piece of code that you've seen in many other places, such as many applications or even both malware and also legitimate software, you are able to distinguish between what is a common code that was seen everywhere, such as libraries or, and code that is specifically unique to that certain connection you have found. So everything that I'm going to present you about our research is based on this point, right? Code connections that we find are actually completely unique to a certain, let's say, family. So as soon as we received the payload from the CCleaner attack, really, let's go back to our case, then we immediately use it to just throw it to our code reuse and similarity system, and then we saw something really special. And let me explain what you're seeing in front of you. So you have let's say, the code similarity result of the stage 1 payload, which was actually injected in memory. So they had like a DLL that was injected in memory, and we just used it to throw it to our system. And immediately we saw something very interesting. 15% of the code of that threat was already seen in APT17. Now, immediately when we took a look on that picture, we tried to remember what we know already about APT17. So they are a very well-known threat actor group with links to the Chinese government, or specifically the Chinese Liberation Army. And these are very, very sophisticated guys. These are the same ones who hacked Google, Adobe, and Juniper back in 2009. And they are specializing in conducting supply chain attacks. So many years before our community has discussed openly about supply chain attacks, they have actually penetrated code inside the Gits, the SVNs, the TFSs of huge companies, really in the goal to backdoor legitimate applications that so many of us are using every day. So really, like, you know, we are all from the defense side, probably, but I know how to appreciate a good work. These guys are doing a very sophisticated attacks that are very hard to both analyze and also to detect. Anyway, so after, you know, seeing just the initial picture of, you know, the connection to APT17, we dived in even further, and we saw that actually there are 4 different variants. You can see, I mean, I don't know if you can see, but there are like 4 rows of file hashes, which are, each and every file hash is actually a different variant of APT17 that shares the same amount of code with the CCleaner hack. So yet again, 4 different variants of APT17 share more than 15% of the code. And then we even dived in even further, and we wanted to see the exact code segments that were similar. But you know what? I just forgot to mention. Just as I said before, these pieces of code, the 15% of the code that was similar, is completely unique and was seen only in CCleaner and in APT17, and not in any other software or malware in the world. And we know that because of that huge database I mentioned before. So this is a very significant connection. But let's see exactly what is the similar code here. So for those of you who don't know assembly, or don't want to know assembly, or can't see, then this is a very interesting implementation, a very unique implementation of base64. So base64 is like an encoding algorithm, right, that is used many times in malware and also in legit applications. And here we see that the whole implementation of base64 is completely unique and was seen only in these 2 threats, CCleaner and different variants of APT17. So this might be a very weird and unlikely coincidence, right? It can be. But then, although you know, as I mentioned before, very, very unlikely since it was seen only twice. But then we had a look also on the second stage payload. So here we see that the same coincidence comes again. And we see another code connection that was seen only in CCleaner and APT17 in the stage 2 of the attack. So just to remind, we're talking about the stage 2 where only specific organizations have received, only the target companies have received. And this similar code, what does it do? It's basically resolving an API function, a Windows API function, to, you know, to continue its operation of that threat. So, for example, you can take a look on the first piece of code. This is how normally, you know, programmers will be resolving an API function. They would call load library and then get proc address to resolve the API, the address of this API function. What we have seen that was unique in these 2 cases is that they actually splitted the strings of kernel 32 and the actual API, Windows API function, 2 different characters. Now, why did the attacker do that, probably because they just wanted to obfuscate the string, to avoid AV detection, signature detection. I'm sure that you've seen many cases similar to these before. But yet again, this is the only, here it's like C++ code, right? But in the end, this is just to explain a bit more easily what the attacker wanted to do and why is it so unique. But almost byte by byte, this is the same implementation and the same code. So the combination of these two evidences makes it not so much of a coincidence after all. And if we also add it up to the fact that this is a supply chain attack, that this is exactly what APT17 is specializing in, we have a more clear view of an attribution or a classification of that malicious code and malware. Now, nothing is sure with attribution and classifying to threat actors. Really, unfortunately, I was needing to do this on a daily job to make attribution to other threats, and it's very, very hard. But when you take a look on the Achilles heel of attackers, which is they have to reuse code, right, to not waste a lot of resources, you get a very clear understanding about who is behind the threat. So just to mention this, although nothing is sure, we have, as an InfoSec community, a better understanding about who we were dealing with in this attack specifically. And I think it's very important for us to know to better understand, the threat landscape and also respond better to future incidents because we know, what we are actually dealing with. So, just to more like sum up what we learned or what I wanted to share. So first of all, and this is a very important point for me to mention, today we see supply chain attacks that are sophisticated, such as this one, being conducted only by nation-sponsored attackers or, if you have nation resources. But what if tomorrow this would be, conducting supply chain attacks would be a commodity, such as many other stuff we've seen in the past, like, all the case of the shadow brokers and so on, that very sophisticated abilities were just now a commodity for any kind of script kiddie. So we need to prepare as a community to deal with these types of threats, because I'm sure that 2 years from now, maybe even less or a bit more, somebody else will be talking about how much supply chain attacks have become a commodity. Now, we don't have a clear solution for that, to be honest, but this is something that we should know and we should be aware of. We have our own solution of our company, not specifically focused on supply chains, but there are many great ideas in the community that we should share and make happen. Secondly, I wanted to show you that threat actors are actually prone to to the problem, or let's say to the phenomenon that any kind of developer is facing, which is doing code reuse. Because, and I really have the experience, have the pleasure to have the experience of dealing with very sophisticated threats. And there you see that nations and just sophisticated attackers cannot really afford to rewrite their whole code from scratch. They just can't. It's extremely not cost effective. Maybe a scripted kiddie can, but if you are developing a serious malware, you probably wasted or spent a lot of years to develop, and you just can't write it from scratch. So here we see a case where several years later, the same attacker still used their same code base. Right? So software is evolutionary, and also malware is, and we see it all the time. And lastly, I wanted to show you how detecting code reuse can not only help us understand whether a file is good or bad, right? Because seeing code reuse, but also it can help us better understand what we're dealing with and how we can respond to future incidents. And another thing I want to mention is that everything that I showed you regarding like the code similarities, technology, and so on, so it's actually completely free to the community. So you can just try it out. And we would be happy to see more people, more faces in our community that we worked very hard to create. And last thing, well, I really hope that the information that I shared today was helpful for you, because for us as a company to see this attack conducted in, let's say, in real life, it was really an eye-opener to think about how to respond to future incidents. Thank you so much.